Devices are no longer just things that people interact with. The Internet of Things is truly here, whether it's in our personal lives or in our enterprise lives. But with extra devices comes much more crowded spectrum. Will 6 gigahertz be the thing that saves us? In this episode of the Tech Field Day podcast, we discuss whether or not 6 gigahertz will clear the way for more IoT devices to be adopted. Welcome to the Tech Field Day podcast, where we bring together a group of influential IT experts to talk about a single idea or a premise about key concepts in the enterprise tech industry. This podcast features a variety of perspectives from members of the Tech Field Day delegate community and is often recorded in association with one of our events. Tech Field Day is a part of the Futurum Group, and this podcast is also published on our sister company's website, TechStrong TV. In this episode, we will be discussing wireless-focused topics, especially around 6 gigahertz and IoT. Before we get to that, though, I'd like to take a moment for everybody to introduce themselves so you know who you're listening to, starting with Cheryl.
Hey there, my name is Cheryl Connell. I'm a senior wireless admin, title about to be changed, at Dalhousie University in Nova Scotia, Canada.
Hi, my name is Jason Beshara. I am a mobility solutions architect. I've worked in wireless now for almost 25 years, which is scary to say that it's been around that long.
I'm Ron Westfall, Research Director here at the Futurum Group, and I head up our coverage of the mobile ecosystem. And that is something that I'm very excited about for 25.
Awesome. Well, thank you all for joining us. As previously mentioned, my name is Tom Hollingsworth. I am an event lead at Tech Field Day. I'm also an analyst that specializes in wireless and mobility technologies. So let's jump into the premise for today's episode. If you are someone who owns any kind of device, you probably know what wireless internet is, right? It's that magical thing that allows me to get on the internet, and it's where my phone doesn't run up my data plan when I'm at home. However, the industry is constantly changing, and we're always adding additional spectrum and even new technology areas to Wi-Fi. And one of the ones that you might have heard of is something called 6 gigahertz. Now, if you're not an electrical engineer, don't worry, we're not going to get that deep into it. But what you need to know is that there are more radio frequencies for your devices to talk on, and that potentially could be important, especially in the arena of Internet of Things, because as it turns out, our tablets, phones, and laptops aren't the only things that need to talk to the rest of the world. So in this episode of the Tech Field Day podcast, we're going to be discussing the fact that 6 gigahertz Wi-Fi is going to change the way that IoT is deployed. Now, I want to jump in here and kind of level set for everybody. We have used a variety of wireless frequency technologies over the years. Originally, when we started, it was 5 gigahertz, and then we opened up the band for 2.4 gigahertz, which most people are probably familiar with. You may have heard it referred to as 802.11 with a letter after it. You know, some of them are B, some of them are N, some of them are A, some of them are G. And then eventually we hit on this brilliant idea of doing marketing numbers. So you probably heard of Wi-Fi 5 and Wi-Fi 6, and of course, Wi-Fi 7. But what we did not discuss is that we opened a new spectrum just a few years ago in the 6 gigahertz range, which is why there is a Wi-Fi 6 and a Wi-Fi 6E. But I guess the question that I kind of want to start off with is, why was it so important for us to open up the 6 gigahertz band for devices to join it with the proper radios?
I'll go. So, with 5 gigahertz, we had a limited amount of spectrum. We had 550 megahertz of spectrum, which in metropolitan areas or high density areas, we just didn't have enough channels. We had 24 non-overlapping channels. So what 6 gig did was gave us 1200 megahertz of untouched spectrum. While there were some incumbents in play within that spectrum, at least while we were able to use low power indoors, it gave us 59 new 20 megahertz non-overlapping channels, which is huge from a wireless perspective. It's the biggest thing that's happened in wireless in 20 years. Going back to IoT and how that's going to be used, I would actually welcome the use of IoT from a Wi-Fi perspective. I'm going to put up air quotes there for a reason. I think one of the biggest problems with IoT right now is the proliferation of bad radios, old technology, old PHYs, and the lack of WPA3 support. Any one of my IoT widgets right now, I have to set up a WPA2 network. So I think if anything, that's going to force the IoT ecosphere, let's say, into using the WPA3 encryption, to using some better mechanisms for securing those networks. I think the problem with IoT becomes from a non-802.11 perspective, right? Because this is an open frequency. So it's not only Wi-Fi that can just use it. I think when we start to see video transmitters, 4K, 8K, which we're already seeing in some events, start to proliferate into the 6 gigahertz band, we're going to start seeing the same issues crop up that we've traditionally seen in 2.4 and 5 with non-802.11 interferers.
And those are excellent points. I think another consideration that reinforces those outstanding points is that it's not required to operate under the control of the Automatic Frequency Coordination System, or AFC. And I think that it will help with the deployments. It will encourage, folks who may have been, holding back a bit in terms of, okay, I want to really find out, what IoT implementations can really take off if we have, these abilities, if we overcome the limitations of the 5 gigahertz. And I think that's important because it's also building in the ability to support contention-based protocol, and also, ensure that power transmission is controlled. And it's also, prohibited from, becoming part of a fixed outdoor infrastructure. So this is, I think, giving the extra assurance, like, okay, yes, this is open. However, we are applying lessons learned to really make it work for real world use cases and capabilities.
I've been interested to see. We haven't rolled out 6 gigahertz yet. It is coming, but work on a campus environment, which is surrounded by a lot of residential. So we hit things where, somebody's putting 40 megs on their 2.4 and taking up all the. And I keep wondering how many people are going to take 320 megahertz channels because they can and just start blasting it. Is the cable company going to set that as, hey, you can have this because we're allowed to do it, and just put it on everybody's home router and cause interference that way? But I haven't gotten to see how it's going to play out yet.
And I think that's one of the things that a lot of people need to understand is that we have always faced issues with resource contention because there's only so much spectrum that's available. And I can remember when I first got into doing wireless, I had access to wireless scanning tools, and I found out that my neighbors were using dual width channels in 2.4, which was basically 2/3 of the available spectrum. And then as I moved more devices onto 5 gigahertz and the channels kept getting wider, 80 and then eventually potentially even 160 megahertz wide channels, it created these issues where the devices that needed those capabilities, say it was a laptop trying to do high speed transfers to like a local storage device, loved it, but nothing else did. And then when I think about IoT, and one of the values of it is that it does use such little bandwidth that we don't need to create these massive wide channels. And yet, when I buy a brand new access point from any one of a number of vendors, when it comes out of the box, it is pre-configured for way more channel bandwidth than it actually needs for a variety of reasons. So are we causing our own problems by setting improper defaults for a given use case?
I'm inclined to say, yeah, that's something that is part of the track record. We've heard how, Wi-Fi can be integral to unleashing use cases, at least making them more accessible, more reliable. And that's one thing I think is important here, is that the very low power devices, or VLD, will be important for very low power devices, or VLP, will be very important for enabling, I would say, like healthcare applications, something that is important for all of society, clearly. And to be able to take, the new capabilities and support it on a more broad basis will be a difference maker, because I think we're seeing more awareness of why health care applications are very important to extend to, say, a senior citizen who can't necessarily go to a healthcare facility and would need at-home support. And Wi-Fi can play a very critical role in that type of scenario. But also in terms of healthcare monitoring, being able to know, what is going on with your body? What's your healthcare profile? And I think this type of technology can help improve that use case and just make it more available to society as a whole.
And adding to that point, especially in healthcare, 2.4 and 5 gigahertz traditionally are extremely crowded. You've got competition from users, devices, patient tracking, multiple different systems that use the spectrum in those verticals. So adding 1200 megahertz of additional new spectrum into those places which are mission critical, or where there are lives at stake, definitely important and are appealing to those organizations.
And Cheryl, you have a unique perspective on this because working in a university, maybe you don't see nearly as many insulin pumps or other IoT devices, but you probably have a ton of things like building sensors that you have to keep track of. And are you seeing more and more deployment of those devices? And is there a corresponding issue with the amount of available bandwidth that you have to use them?
Yeah, and we've also had things where they're trying to replace some of the custodial jobs with the IoT mops and vacuums that connect to the 2.4 only. And some of the areas they're using in our setup may have deemed 2.4 not necessary in that area, and so we've been finding these holes. But yeah, there's robotic mops and vacuums popping up all over campus. The HVAC controls. We've had some solar monitoring put up on roofs. Yeah, there's just been various things coming up, and then we've got all the students coming in with their, what do they call, wearables, I guess, and researchers everywhere with trying to get VR headsets and things. And I know that came up a lot in some EDUCAUSE discussions and some WLPC people that do higher ed things with how do we get these VR headsets on the network and all the things that had to be adjusted for them. So.
And I'm glad you mentioned that, Cheryl, because as we've seen, augmented reality and virtual reality have, taken some lumps in terms of, okay, here is a use case that was highly touted, but hasn't really quite, met expectations. And so it's been dialed back. Well, here is a technology that can, I think, re-energize it. And I think those are excellent examples, VR headsets amongst the student population at a university campus. This is, I think, a use case that is well suited for that. But it's also interesting in talking to businesses out there, organizations out there, that they are actually learning how to better leverage VR and AR capabilities for improving business outcomes. One example is construction sites. They have actually are finding that by using AR capabilities, they can actually improve the design of what's going on at the construction site, how to ensure that safety is being upheld on an optimal basis. Basically just improving the overall process by using that. And they have to use, a Wi-Fi connection, or now they can start using the very low power devices to really make a difference in terms of the flexibility of using that. So this, I think, can be good news for AR, VR and help, make it more interesting again.
I think you're right, Ron. And there's a number of use cases that have cropped up over the last several years that are becoming more and more important. Things like, personal devices, wearables, VR headsets, those kinds of things. But I think there's another impact to this that a lot of people aren't understanding, and it's the fact that certain people expect an environment that they maybe aren't able to get. And an example that I used when right before we started this recording is something like a touring music artist, right? They have a kit that they put together that works. And that kit usually involves things like wireless microphones, wireless cameras, and those kinds of things, right? Well, when they come to your location, it could be a stadium, it could be an arena, maybe they're playing on a lawn at a college, who knows, parking lot at a hospital. They need their kit to be the only kit in the area that works. And it could be a situation where in the agreement that you have to turn everything off in order to be able for them to be able to be there. I know that when I took a tour of the 49ers stadium in Santa Clara, California, one of the things that the designers said is that the antennas that are around the the fan area that provide Wi-Fi for the field must be disabled when certain concerts are in town, because the radio microphones on the field cannot be interfered with in any way, or it costs the stadium money on their contract. So do you see these kind of external influence situations causing hiccups in the IoT space? And is 6 gigahertz a way to kind of solve them?
I think it's going to be a way to solve them for the short term. As we start to see the proliferation of these non-802.11 devices into the 6 gigahertz space, which we already have with video transmission, audio transmission, we're probably only going to see more of that. Much like we have with occupancy sensors in upper 5 gigahertz bands. Those have become really popular in the past few years. So as long as Wi-Fi plays in unlicensed spectrum, we're always going to have to worry about incumbents and non-802.11 devices that are going to want to use some of that spectrum.
And I think, yes, the benefits I mentioned can help assist with that. But as we know, it's all about the real world implementations. And yes, I think the external factors will influence lessons learned. That is, okay, how can we make just that, the devices more capable of adapting to the environment that it's being implemented in? And I think one thing that will help the uptake is that VLP, I think, has kind of a built-in marketing advantage, in that everybody out there supports better energy efficiency. Is this a way to actually get the same results or improved results in terms of using a Wi-Fi type of implementation, and then seeing the use cases that we just talked about? And so I think that will be a catalyst of sorts as it now becomes more popular, becomes more widely deployed, tested, and so forth, thanks to the FCC's recent decision.
Lighting systems were another one that just came to mind when you guys were talking about that. We have a lot of new green energy lighting systems coming up, and they are constantly interfering with things. So if there was a way to move those, that would make my life a little easier.
And I think one of the things that people have to understand is unlicensed does not mean it's the Wild West, right? Because we've seen that with even Wi-Fi vendors in the past that just assume, oh, well, I'll just play wherever I want, and you guys have to adjust to what I want to do. And we actually saw an order that came down from the FCC in recent weeks of the recording this podcast, where originally the lower part of the 6 gigahertz band was restricted from low power IoT devices, because there wasn't a clear answer as to how much interference they could cause for things like incumbent satellite downlink providers. But we've now seen guidance from the FCC that says that spectrum area can be opened up again and should be able to be used in low power situations. Of course, it still needs to meet the requirements to be able to behave in 6 gigahertz, and they're still not available for things like outdoor broadcasts. But are we going to start seeing more restrictions being put in place, even though it's an unlicensed spectrum, to prevent the kinds of collisions that could interfere with incumbents in the space, or even entrance into the space, as we continue to get more people that are starting to use it?
From at least speaking from a wireless perspective, I certainly hope so. Learning from some of the issues that we had in the past with 5 gigahertz and cellular, I think that would be a welcome adoption.
Yeah, I think CBRS lends a case study as to how this will probably evolve. That it's not going to be a Wild West scenario. There have already been built-in mechanisms to help with the interference issue, but then it always comes down to the real-world implementations. And so, there will be some refereeing out there that will come up as results, I expect, if past history has been a lesson. And I think those are excellent points about what's happened with 5 gigahertz in the cellular realm, and hopefully the lessons learned there can help advance these capabilities with less impediment.
So I guess my next question is, of course, going to be the fact that most people really don't have 6 gigahertz deployed widely today, because it's only been around for a few months as a legal, maybe not the right word, more of an approved solution. And as companies are trying to decide, is this something that I need to deploy? Are there any compelling use cases for it? Or are we going to be finding ourselves in a situation where we're probably going to be deploying the IoT devices first and then moving them to 6 gigahertz as our infrastructure catches up to the capabilities of the clients?
Can I say the magic word?
Go ahead.
It depends. So, I would say, for instance, I had a particular engagement about a month ago where 5 gigahertz for this particular customer was totally shot across the board. It was in a very busy metropolitan area, and Spectrum was trashed from an external source. So in that case, we had a very compelling case to move to 6 gigahertz. Again, it's going to depend upon what your refresh cycle looks like, what your existing clients look like. Do you have clients that support 6 gigahertz today? Unless your devices are Apple, recent Apple iPhones 15 and 16s, or recent Samsung or Google Pixel devices, you probably don't even support 6 gigahertz on a lot of your end client devices, especially IoT. I think one of the things that Cheryl had mentioned earlier was, she's got all of these new gadgets, these robots that do these things, and myself, I've been in the healthcare industry. You have brand new scopes. And while it's a brand new technology, what they're not looking at is the radio card that they put into it that is a 10-year-old technology. And unfortunately, when you're building these things at multiple units, the chipsets add up. So they look for the cheapest part there. So that's why we end up with those cheap IoT radios.
Well, those are outstanding points. I think it's, we've seen this in the wireless ecosystem before. It's like, okay, 5G, when it was first built, had to have a non-standalone implementation. And it wasn't until standalone became more broadly implemented that, okay, 5G was able to demonstrate more value, relatively speaking. And what I think is distinct here is like, okay, it's the ecosystem that will have to play a role. And there's going to be push and pull that reinforces the "it depends" axiom, and that is, I don't think you're going to see chip makers and access point makers or IoT sensor and device makers rushing out and support 6 gigahertz because it might re-energize more AR and VR. However, what I think we can somewhat anticipate is when it comes to entertainment. This is something like, oh, okay, people are really taking advantage of 6 gigahertz capabilities to, do more entertainment viewing, something that can actually generate more near-term dollars, I would expect. And this includes gaming applications. It includes naturally the Netflix and the video streaming and the other applications that we touched on. So I think this is going to be again that mosaic of, okay, here are the different drivers. Some will stand out before others, but ultimately, as the ecosystem matures, this will just reinforce why 6 gigahertz support is critical.
Yeah, and we come in a very bring your own device environment. So I was just actually looking. We in the last 6 months we've moved from our Airwave environment to Aruba Central, and I was looking to see if I could still run reports that showed. But we had G clients. There was only a handful of them, but they were connecting at G still, and it was just they were in a isolated area and they could do N, but we still have a number. But 85% of our devices now are Apple. Or some sort of Apple OS device. So we are at the point, but there are NG only devices on our network, so we couldn't get rid of the 2.4 only, even if we wanted to.
And that's one of the things that I actually ran into a few years ago, is that I wanted to disable low data rates in my network at home because, that's just a thing you do. And then people started complaining that their old gaming consoles wouldn't work, or some reason this IoT device suddenly disappeared from the network. And I think that's something that people need to understand, is that even if you buy something brand new, there's no guarantee that it's going to work the way you want it to. I mean, a good example of that is if you're using HomeKit for an Apple device, and HomeKit is fairly advanced, right? You still have to have 2.4 gigahertz radios enabled for HomeKit to operate, because a lot of the IoT devices that are out there never moved to 5 gigahertz. To Jason's point, the reason being is because 5 gigahertz radios for those devices were more expensive. And when I say more expensive, I'm not talking about the difference between $4 and $2. I'm talking about the difference between 75 cents and 50 cents. But on the scale of needing to manufacture 10,000 of those devices, it was enough to cut into their profit margins. Will that mean that 6 gigahertz is something that everybody adopts because it's better, it's more efficient? I don't have a good answer. I will say that the adoption will be driven by need or by cheapness. And if there are a lot of devices out there that make that switch and say, we're only going to operate on this band, or we're going to operate most efficiently in, say, low-powered 6 gigahertz, then I think people are going to adopt the underlying infrastructure. However, if, to Cheryl's point, if you still provide support for the oldest of the old devices, and people are never going to upgrade them because they don't have to. And we've seen that a lot in other spaces in the IT industry. There's a reason why you're not running this over IPv6. And if you are, congratulations, you're ahead of the curve. So I don't know what the answer is going to be ultimately, but I think that we're going to figure it out because we're going to be the ones that are going to be implementing it. All right, that will just about do it for this episode of the Tech Field Day podcast. I want to thank everybody for joining us. Before we go, if people want to check out some of the information that you guys as IT experts share with your communities, where can they go to see that, Cheryl?
For me, it would be gingerfiat.ca, or you can find me on LinkedIn. I'm on Twitter a little bit still, or Blue Sky.
I'm on all the socials at my name, Jason Beshara. Probably not been as active as I'm about to start being again, but here we are.
Thank you, Tom. That is a softball. And you can certainly find me on the Futurum Group website. And that certainly includes Tech Field Day content. But also on social, yes, I'm on LinkedIn and also on Twitter X, I'm Westfall DX. And so those are the ways that I would certainly welcome interactions.
All right. And we want to thank each and every one of you for listening to this episode of the Tech Field Day podcast. If you enjoyed our discussion here, please make sure you subscribe on our YouTube channel or use your favorite podcast application of choice if you prefer the audio-only format. We don't want you to miss a single episode. And if you do, please make sure you give us a rating and a review so people kind of see what we're all about and kind of understand the topics that we're going to be discussing. As always, this podcast was brought to you by Tech Field Day, the home for IT experts from across the enterprise, and the Futurum Group, which is the owner of Tech Field Day. For upcoming events and more information, please make sure you check out our website at techfieldday.com/podcast or check us out on TechStrong TV. Thanks for listening, and we'll see you in the next episode.